Yeah, cool. Yeah, so thanks a lot for the invite and thanks for the great introduction. So the idea in this talk is to talk about broadly some of the work that I've been doing on misinformation on WhatsApp over the last, let's say, year and a half that I've been at MIT. And this is joint work with a lot of people, mainly people at MIT, but also folks from Brazil. So from this institute called UFMG in Brazil, they've done a bunch of work and we've collaborated quite a bit in using their data and our data and doing stuff together, in a multi-country setting. So I'll talk about like all of this as my work, but it's actually a collaborative work. That's something I want to make sure. Okay, so WhatsApp, I'll just give you a very brief introduction about WhatsApp for people who are not familiar with on why it is really, really important. So WhatsApp is this one-to-one messaging platform, very, very popular, 1.5 billion monthly active users. Things that make it different from other social networks is that it's multimedia heavy. So there's a lot of images and video. In fact, in our data, we see that over 50% of the content is non-textual, which is not the case with, let's say, Twitter or Facebook. And it's also end-to-end encrypted, so there's no API where you can get data.
Did we lose Kiran? I can't hear you anymore. Your audio is just cut out, I think. Or is it? Can anyone else hear Kiran at the moment? No.
Nope.
Oh, yep, you're back now. Perfect.
Yeah, I don't know. Sorry about that.
No worries. As you were.
Oh, okay. So the next billion, like these are people coming online for the first time through cheap smartphones and like cheap data in countries like India, Brazil, Mexico, and so on. Like the global South primarily are on WhatsApp. So that's really an interesting aspect for WhatsApp. In these countries, WhatsApp is like the replacement for the internet, right? Like so, a lot of people have Android phones, and WhatsApp comes pre-installed on 95% of these phones. And so you have these huge numbers here, like 400 million Indians are on WhatsApp. Almost 100% of Brazil's internet population is on WhatsApp, and 50% of Zimbabwe's internet traffic in 2017 was on WhatsApp. So this shows, the scale at which WhatsApp is being used in these countries. So I'll give you a couple of examples on why WhatsApp is an important social phenomena that we should be studying as computer scientists or social scientists or as communication scholars. So firstly, I gave you a few examples of its global scale popularity, especially for first-time internet users. This particularly leads to changes in the social fabric. So people like this person. So this is from the Wall Street Journal, where this talks about people like this who were not able to read or write are now able to access the internet because of voice and video features provided by chat apps like WhatsApp, right? Like so. These are people coming online, and so WhatsApp and platforms like that are enabling people like these to communicate and come online. There's some funny bits where Indians, for instance, are sending too many good morning texts, and so it has apparently become a huge technical challenge for the Silicon Valley companies and how to handle that. So that's new, like people coming online and they're experiencing this new reality. Of course, it has some cultural differences, right? Like, so there are people who are old, but also now coming online. There's the younger generation. There's some clash between them. But it's all not that funny and cool. There are adverse consequences because of things like misinformation and rumors. So in Brazil, 2 years ago, it was claimed that during the elections in Brazil, propaganda was spread extensively in a coordinated fashion through groups on WhatsApp. Right, and similarly, like dozens of people were killed in a large number of countries, primarily India, Mexico, but because of child kidnapping rumors that spread through WhatsApp, right? And there are these adverse consequences. So that's one, especially for the global south, where people are coming online for the first time. WhatsApp enables this massive spread of information in a very fast manner. So that changes the dynamics. So that's one thing we should keep in mind. The other is this closed nature of the platform. So it's all end-to-end encrypted, and so you can really have bad actors misusing the platform for a lot of purposes. I'll give you two examples. So the first is an example from some of our work. So this is a screenshot of one of our phones where we were collecting WhatsApp data. So here I'm showing you 6 or 7 groups. All the groups here, except the first, have a very typical structure. So there's an ID for the group, there's a name, which is the name of the party, and there is a constituency, or like a voting district. So this party, which is the party that's currently in power, has created thousands of WhatsApp groups. So here, in this particular case, we have 290 groups that belong to a certain region, and each sub-region in that has a WhatsApp group. And what is shown here is that the same message was sent in all these groups at the same time, right? Like, so there is also some sort of central coordination happening. And in our case, in our data, we observed over 5,000 such cases of the same message being sent in over 20 groups in a 10-second window. So not all of that is bad. Not all of that is misinformation, but still, you can set up these sorts of, large-scale groups that are unmonitored, so nobody is monitoring them. There's no content moderation that you could potentially use for spreading propaganda or hate or whatever. So that could be possible. So that's the first thing. The other is slightly amusing and scary. So the first in the wild use of a deepfake video was done in the elections that took place in Delhi 2 months ago. So this was in February. So these are the two deepfakes. So this is a politician from that Delhi region. So what he did is, so India is a very diverse linguistically, you have many languages, many that people speak. So there are over 24 languages. This guy does not speak some of those languages. So he created a deep fake of himself speaking those languages. And so he just wanted to reach an audience that was different. I mean, that was different from his traditional user base. So he created these deep fakes, right? So that's probably, so these are very well done. So you really, if you just see them, you cannot say that, tell that these are manipulated videos. So these are deep fakes. But that was a positive use case, right? Like, so the guy did not mean anything negative. He did not mean any harm. So he just wanted to reach a different audience. But the scary part is here. So this was reported in an article by this Vice News. And so this is a quote that I highlighted from that article. So here it says, these deepfakes were distributed across 5,800 WhatsApp groups in that region, reaching roughly 15 million people, right? So this is the scary part, because so this video, the article came out 2 weeks after the election. So during the elections, nobody knew that this kind of videos were spreading on WhatsApp, because there's no, it's all end-to-end encrypted. Nobody sees the content that is spreading on WhatsApp. So if these people who created these videos did not come out and tell us that, hey, we created this deepfake, nobody would have known about it, right? And so we don't know currently to what extent there are such videos that are spreading on WhatsApp, because there's no way to know. And so in this case, it turned out to be a positive video, but it could as well have been a foreign actor or a hostile actor who could spread things like misinformation or propaganda or hate. So that closed nature of WhatsApp actually makes it quite dangerous. You don't have an understanding of to what extent the reach of certain pieces of content is on WhatsApp. And so there are really global lessons to be learned from WhatsApp, because you never know how these platforms could be weaponized. And so it's really important to study these things at scale. So that was quite like a very broad, like very long introduction about the importance of WhatsApp. I'll now talk about, in the next 30 minutes or so, three things that we've been working on. and give you like high-level summaries of each of these. If you want, I can go deeper into any of these, so feel free to stop and ask me questions. If you have any questions, just please let me know. Cool. So let's get to the first part, which is, let me just move this here. Okay. The building tools for getting WhatsApp data. So one of our contribution in this work is actually developing tools to monitor large-scale data from public WhatsApp groups. So these are groups where the admins made the link to the group publicly available. So anyone who has a link to the group can join. We find lists of such groups from sources like the web and social media platforms, mostly manually. And then these groups are actually quite small, limited to 256 members per group. So we created this tooling where, given an Android phone and a list of groups to join, we automated the process of joining and exporting the database from WhatsApp. So we have publicly available code here and detailed instructions on how you could replicate that. And so we are specifically focused on political groups, public groups that discuss politics. And these are actually quite popular in countries like India and Brazil. Like, so here's an article from the New York Times, which talks about the central role of WhatsApp. And so this was also 2 years ago. There was a local election where apparently 50,000 WhatsApp groups were created by the parties to spread their messages. So there's a very clear WhatsApp strategy now for a lot of these political parties. Like, political parties now have Facebook strategies and other social media strategies. Parties in these countries have now WhatsApp strategies where you have different hierarchies of groups that are created and content flows from the top. So someone in the political office and the party creates some memes and some content and just push it down to the WhatsApp groups, and eventually it reaches a lot of people on the ground. So that's how these groups are set up. And in fact, like, surveys that were done show that on ground, like 1 in 6 WhatsApp users in India and 1 in 5 WhatsApp users in Brazil said that they were a part of some of these public WhatsApp groups that discuss politics. They're actually quite widely used. So they're not a fringe phenomena or not a small part of what the actual population of people who use these groups. So in our collection, we got data from India, Brazil, and Indonesia, all around the election period in these 3 countries. Overall, it's over 5 million messages, including images, video, audio, text messages, and so on. It's the total data is over 10 terabytes. It's very large data. So one thing I quickly wanted to point out was that this is not a trivial infrastructure as well as a logistics challenge. So the idea is, it's not like you have an API where you get data from. Unfortunately, it took a lot of effort. So we bought over a dozen phones, and we had to maintain them. We had to make sure they're charged, they're connected to the internet, they're rooted, and so on. We installed like 20 SIM cards in these phones, and then had a way to automate like a certain process, like finding the groups, joining the groups, and then export the database every week, and then send it to our processing pipeline where we download images and video, which are also encrypted. You have to decrypt them and download them. You group together similar audio and video and so on, and you feed them into some of our front-end needs. So this is a very complex pipeline that was involved in actually making sure that we get all of this data and making sure that this runs, for the 3 countries during the respective elections. It was a non-trivial challenge. So one of the front ends that we made available publicly using this data, it's called WhatsApp Monitor. This is in collaboration with the guys from Brazil that I mentioned. So it is a dashboard. Currently, we have it in 3 countries. What it does is it shows the most shared images, messages, video, audio, and URLs across different dates. So you can aggregate across different dates or across different languages or political parties. So for instance, you can ask, hey, what were the most widely shared images during the election period, and it'll give you aggregated information. on it. So it's a very simple dashboard from a computer science, from a developer perspective. You just get the data, aggregate the data, and show it to people. But this was really widely used during the elections in Brazil. So this was used by over 100 journalists and fact-checking organizations to debunk various targeted disinformation campaigns, which were, I mean, there were so many of them. And this was kind of the only source for debunking, for monitoring WhatsApp at scale, right? Like given the fact that we are monitoring thousands of groups, so it'll give you this macro picture of coordinated activities, like who's posting what in what groups and so on, which is really hard for a journalist to get as a picture for if you're just part of a few dozen groups or 100 groups or so on. So this is really important. So I'll just very briefly show you a case study of how our tools were useful. So, this is an example of a very targeted disinformation campaign that took place in Brazil. So exactly almost a year ago, the Brazilian government wanted to announce funding cuts for universities, for public universities. So what they did is just 3 days prior to starting this announcement, they started sending images in these groups that they control about how universities are being used for just having sex and having parties and things like that. So there's some graphic images. So I'll quickly remove that. So, images like these, like people nude and having sex and partying and things like that. And so we were able to observe this campaign because we were able to monitor, all these hundreds of WhatsApp groups. And, we gave access to this to fact-checking organizations. And so fact-checking organizations wrote about it. And so this was, I mean, to a certain extent, the negative intent of this disinformation campaign was already exposed by the time the campaign ran, right? So there were so many cases of such things happening, and our tool can only enable the debunking of a few of them, but at least it does catch that there is this sort of an organized campaign going on and who's behind them, what groups are doing it, and so on. So it is quite helpful in doing that. Right, so that was about the tools and dashboards that you can build on top of those tools. So let me now look at some of our work about misinformation in the form of images on WhatsApp. So like I initially said, a lot of content on WhatsApp is in the form of non-textual. So 35% is images, or over 15% is video. So there's lots of non-textual stuff. So in this work, we're trying to look at misinformation in the form of images. Like how are images being used as misinformation, right? So before I go into the details, there's some technical issues here. So we have millions of images. So we cannot, in order to make sure that you can handle millions of images, we use this technique called perceptual hashing, which groups together similar images. So for example, let's compare these 4 images. So all these 4 are actually the same image. So the text on the image and the person who's represented here is the same, but each of the images has a different property. So the first image on the left has a black border. The second image has a watermark and a red watermark and another watermark. The third image has a different background color. The fourth image has a different color scheme. So it's a very hard problem actually to identify that these are the same image if you do pixel matching, but there are techniques to overcome this. These are called perceptual hashing, where the idea is just to match, group together similar images by generating hashes and then using these hashes to cluster together the images. I guess there was a question. Oh, okay. Cool. So basically, okay, once we generate the hashes, then we cluster together the images based on these hashes. So, if you have 1.5 million images, then you group together images that are perceptually similar, so that look similar, just slight variance of each other into the same, and you reduce your space by almost an order of magnitude. So that's the pre-processing step that we did. Then what we did is we had professional journalists, 3 professional journalists, annotate a sample of 2,500 unique images. So these are unique clusters. So we had to hire experts like journalists to do this task because it was a non-trivial task to detect if an image is misinformation or not. And because these journalists work in this space and are aware of the domain and the political landscape, it was easy for them. I'll not go into the details, but these 2,500 images were sampled carefully. That covers both, a random sample as well as a sample of highly shared images. So we can compute like the prevalence of misinformation and the possible shares of misinformation. We built special annotation tools for the journalists. So here's how it looks. So you have an image and you have some options, but you also show them the context in which this image was shared. So the messages around which that surround this image, because actually context matters quite a bit in understanding image misinformation. So we had to build these tools. So overall, this annotation resulted in roughly 800 images being labeled as misinformation. So out of the 2,500, 800 were labeled to be misinformation. But because we sample them in a certain way, so there's a mix of a random sample and some popularity-based sampling, we can go back and do some sort of inverse probability weighting and estimate the prevalence of misinformation in the entire data set. So this is what we came up with. So 13% of the images that were shared in our data could be misinformation. So that is quite a large number, right? Like 1 in 8 images contain potentially misinformation, which is quite surprising and shocking. I mean, of course, this is only for these public political groups that are in our sample. Our sample is definitely not representative of the entire WhatsApp population, but still, like I said, like given that these WhatsApp groups, the political WhatsApp groups that are public are quite popular, are being used quite a bit. This 13% number is quite concerning. Right? And so one thing we wanted to check was if there was a lot of shares during the elections in India. And so this is a timeline of the number of misinformation images shared across time. And apparently the most number of misinformation images shared were not during the election, but was during this India-Pakistan conflict. There was a terrorist strike in India, and then India struck Pakistan back. And there were lots of misinformation images shared during that period, going up to 2,000 images being shared just in our data set per day. Right? And then, yeah, the elections actually are a smaller peak. Even they are not, smaller compared to the other peaks, but they still go up to roughly 800 to 1,000 images, misinformation images consistently over this few weeks period of time. Right? So that's a lot of misinformation images being shared over in these WhatsApp groups. And one small, interesting information is that a lot of these misinformation images, they last very long. So we plotted this CDF of misinformation, compared that with images that are not misinformation, labeled to be not misinformation, and a random sample. And we find that misinformation images last long. That's one, compared to this other two sets. But also, if you look at the star, that corresponds to images that last over 100 days. So 50% of the images last over 100 days. That means, they just keep getting shared again and again. So a lot of these images get reshared again and again. So that's a very common trend that we see in our data. I'll get back to this in just a moment. Right? So these images, they last quite long. That's flashlight. Okay, so now we wanted to qualitatively look at we label these 800 images as misinformation. Are there any specific underlying patterns of how images are being used for sharing misinformation? So we find 3 main categories of misinformation that make up roughly 70% of our image misinformation. The first one is images that are old, that are taken out of context. So this is exactly the type of images that are reshared again and again. So for instance, an image like this. So this is an old image of a plane crash 5 years ago in India, but this was during the India-Pakistan conflict last year. This was shared widely, claiming to be an Indian plane shot down by Pakistan, which it was not. And these types of old images taken out of context, they have a name. They're called cheap fakes or shallow fakes, because they're the counterpart of deep fakes, where these are very cheap to produce, right? Like you just have an old image, you say something out of context and reshare the same image. So these are very, very popular. The second type of misinformation is images that contain false quotes or statistics. Uh, so these are typically what we call memes with a lot of text on the image. Here's a few examples. So here is one in which it claims that BBC declared BJP, which is the current party in power in India, to be the most corrupt political party in the world. No such survey took place ever. I mean, there was also this counterpart, which is where the BBC actually declared the opposition party as the most corrupt political party in the world. I mean, both of them are false. They never, there was no such survey. But there were a lot of like these sorts of fake quotes, like someone saying something great about the Prime Minister of India, or someone saying, hey, the United Nations recognized India as the most whatever powerful country in the world, or something like that. Like a lot of those sorts of false quotes or false statistics with text on the images, right? Like, so there's these also make up roughly 30% of the misinformation. And finally, the third category is very simple photoshopping, right? Like these could be benign photoshops, like this image is, it claims to be the largest snake found in the world, which, I mean, it is quite obvious, maybe not obvious for a lot of people, but at least for if you know basic photo manipulation skills, you can tell that this doesn't look real. But maybe for a lot of these first-time internet users, it might not be it might not be quite evident. So there are a lot of these benign photoshops, but there are some which are malicious as well. Like these are two examples of these are both photoshopped images. So they appear to show screenshots of TV news programs, but this text here has been photoshopped on the red background. So these appear, I mean, so these are quite popular. These were some of the most shared images in our data. And so the idea behind these, there are a lot of these sorts of examples. The idea behind these is that if people think that it appeared on TV, they might be more likely to believe that this was real. And so and we see that they were shared quite widely in our data. It's also quite hard to tell that these are actually false, right? Like, I mean, if you don't, it's hard to tell that they are Photoshop if you don't know that it didn't appear on the TV at that time at which the program aired. So, these are surprisingly simple Photoshop, but really hard to identify, especially if you're looking at it on your phone. So, okay, to summarize, roughly 70% of our images that we label fall into these categories. I mean, the exact fractions might differ, but there is research that was done elsewhere. This is all, I mean, done during the US 2018 midterms, also even recently during the coronavirus pandemic, like looking at misinformation. And a lot of these categories actually still hold. Like, these categories are consistent across not just in India, but also in the US and UK, people have observed same types of categorization. Right? So now we want to see if we can build some sort of solutions for identifying this sort of misinformation. So I'll very quickly go through a few of the stuff that we have worked on or are working. Before that, just to quickly recap, like WhatsApp is this end-to-end encrypted platform. So there's no content moderation. So you should be aware of the fact that it's when person A sends content to person B, it's encrypted on the person's side and then decrypted only on the other person's phone. So there's no way that WhatsApp can see what content is actually spreading. So you cannot use a central moderation or have some automated content filtering on their server. So that's not possible because of the end-to-end encryption. We should keep that in mind when developing solutions. We have 4 potential solutions that we worked on, and I'll just briefly go through them. So the first is on-device fact-checking. So this is based on the fact that there's this 30% of the images which were old images that are reshared out of context. So if you can have a database of old images that were already fact-checked to be false, then you can implement something on the device of the user that can prevent this from spreading. So here's how it works. You have a data structure of hashes of old images that are already fact-checked. So these could be images that Facebook is already fact-checking or using their content moderation platforms on Facebook. And you can push this onto the device of a user. And then when the user wants to post something on the device before the stuff is encrypted, you can check whether this was already posted, it was fake or not, and then flag the content accordingly. You can do the same on the receiver's end. And this surprisingly works well. I mean, we tested this for Brazil and India. The summary is that if you implement this on device where you prevent the spread once the image has been fact-checked, roughly 40% of the misinformation shared in Brazil and 80% of the shares in India could be avoided. In our data set, I mean, this is work on a small data set from these two countries. This is not generalizable, but still, I mean, 40 and 80% are a large fraction, especially if you're taking into account these cases like election manipulation or rumors that get people killed or stuff like that. Even if you can stop the sharing of a small fraction of such information, it makes a lot of difference in actually preventing bad things from happening. So just to recap, so we have the solution, which is on-device fact-checking. It works. It's quite privacy preserving, but it depends on the availability of this fact-check images, which is not scalable, and it can also be gamed. Like maybe, I mean, because it depends on how hash lookup. So there, it might be easy to game this kind of a solution. So because it's not scalable, you can think of machine learning models, which are quite scalable. You can use features from various types of the spread of misinformation and build a machine learning model. So yeah, the basic features that we used in our tests were based on some metadata related features, like who posted these images, where were they posted, like what groups were they posted, how long did they last, and I showed you a few examples of how these features could actually differentiate between misinformation and not misinformation. Then there is content related features. I mean, this is just out of curiosity. Like I said, like WhatsApp cannot see the content, so this might not be practical to think of using these features. But out of curiosity, we looked at if the types of images, right? Like, did the image have text on it? Where did the image appear on the web in the past? What objects were in the image? Like, can you use some sort of pre-trained embeddings to get sort of an embedding for the image and use that as a feature? And so the results are like that. This is a balanced classification. So 0.5 accuracy should be random. So we get non-random accuracy. This is not, I mean, far from perfect, but still non-random, 0.67, 0.78. We also did some other robustness checks and found that these content-related features are not stable over time, and that is kind of expected, especially given our small sample. When you train on a certain time period and test on a time period different from that, the accuracy actually falls quite a bit and becomes almost random. But the metadata ones are still robust. So the second solution is based on machine learning, which is scalable. I mean, you can really implement these models, especially one based on metadata, but it's not live, as in the metadata features like who is posting or how long did they last. They might not be available while the images are spreading, so you might need some of these features to get that accuracy, but they're not likely feasible. And so the third solution is based on community-driven fact-checking, right? Like, this is based on the users in the groups themselves fact-checking the content. So this solves this issue of not being able to fact-check live. So this is on-the-spot fact-checking because it's like a chat platform. So here's an example. So this is a screenshot from one of our groups. So here a person is saying, beware, these are child kidnappers found in this region. Please forward to catch these idiots. And so there's an image of alleged like child kidnappers. So someone else replies and says, this is fake, don't forward it. I saw this on some fact-checking website, right? Like, so this is the best solution that WhatsApp could think of. So if people can themselves correct misinformation that is shared in these groups, and because we have a lot of this data, we have thousands of such cases. So we know cases where people were actually fact checking. So this is ongoing work where we're trying to find out like who is fact checking, like what are the characteristics of people who fact check, what content is fact checked, who is fact checked, and how do the users react to that, like both longitudinally, like do they post less misinformation after being fact checked, or how do they react immediately after being corrected, because this is a community when you're correcting people in front of everybody, so might not work as expected. Anyway, so the community-driven efforts, the solution is live. It works, on the spot. So if someone posts something, there's a chance to correct that. It's also scalable. Like if you can identify who's more likely to do these and incentivize these fact checks, then it could be scalable. But anything you have where you give power to the community or give power to people, it's really dangerous. So you should, it might look quite nice and sweet that this could solve problems, but it might create many more problems than solve problems. So we should be very careful about that. Then the final solution is based on what WhatsApp is already implementing. So it says, let's not look at any content or any spread related information. Let's just say limit how images or how content can become viral. So let's introduce friction into content becoming viral. And so WhatsApp is implementing by introducing these forwarding limits. So they're now saying you can only forward at once to 5 individuals. Actually, they changed this just last month to say you can only share, you can only forward these frequently forwarded information to one person. So they changed this from 5 to 1. Anyway, we did this back when they changed it from 20 to 5. And so we use this sort of simulation models. They're based on the spread of like information in the network. So you simulate the spread of information in the network that we have. And what we find is that such limits to forwarding can reduce the velocity of dissemination. So they do actually work. And they reduce the velocity by an order of magnitude. So they do slow down the spread by a lot. Like you can really slow down by an order of magnitude. But eventually, if you don't have any other checks, if a user really wants to forward, they can just forward to 5 people at once or forward to 1 person at once and make sure that the content spreads to the entire network. So these things might not completely work, so they work to a certain extent. So basically, yeah, the reducing virality slows down the spread, but it's not just sufficient. So basically, yeah, this is the recap of all the solutions that we have tried. Each of them has their own benefits and negatives, but they don't completely solve the entire problem. Maybe there's no one solution that solves the entire problem, right? So just one final thing that I want to talk about is looking at like who is sharing the misinformation and what and why. And this is what we are trying to do now. And this is slightly, this is what we are trying currently do. This is based on the idea of combining our observational data that we have with some sort of experiments that you can do, where you can ask people why and understand who. So here's how it works, right? Like, so let's say you have an image that this is the photoshopped image that we have in our case. In our data set, in our large data set of millions of messages that we collected, we can identify the users who got exposed to this image. Right? Like we know what all users were part of the groups that this image was shared in. And so you can get observational data from these people. So you can say, look at what these users also shared otherwise. Like, did they share other misinformation? What other information did they share? But that's all you can answer about from an observational perspective, right? Like you cannot answer, did they believe that this is misinformation? Would they have forwarded it further, like, and things like that. So what we are trying to do now is use this set of users to target an advertisement to them on Facebook. So this is based on Facebook's personal targeting features they have in their advertising manager, where we can ask them a question like, do you remember seeing an image like this in the past? Would you want to take a survey? And the survey has questions about like, hey, who did you get this from? did you forward it? Do you think it is true or not? And things like that. So we're trying to do these sorts of surveys. And then the great thing is just, combining this power of observational data where we know some sort of ground truth on what people got exposed to, along with these sorts of surveys where we can get detailed information. So this is a very powerful tool. You can, this is very scalable, very targeted. So you have, we have, I don't know, millions of images, out of which at least a few thousand can be used to target people and ask information about. And you can really do this sort of a live online field experiment. So that was kind of it. I think I can take 5 more minutes, right?
Yes, absolutely.
Cool. So I just want to show one more, which is not specifically about misinformation, but it's a very cool thing that we also found that we're working on right now. So it's based on this idea of cross-platform coordination. So WhatsApp, again, the 10th time, is closed platform. We don't know what is going on if you're not part of some of these groups. So what people are doing, especially we found a lot of examples like this in India, is use WhatsApp groups to coordinate trends on Twitter. So this is how it works. So the political party that is doing this is the one that is currently in power. What they do is they have these thousands of WhatsApp groups, and they create a Google Doc which contains a hashtag and tweets related to that hashtag. And they send this in these thousands of WhatsApp groups that contain their party supporters. And these are, it's a Google Doc containing template tweets. So for each hashtag, you have a hashtag, you have a date and time, and you have example tweets that people can talk about related to that hashtag. And the way it works is people just copy paste that tweet. So, you have a tweet, then people copy paste that tweet on their Twitter handle. So this is coordination on WhatsApp going to Twitter. So people getting things trending on Twitter. So you have a few hundred examples of such tweets for each hashtag, and then a few thousand users, and it's very easy to actually get these hashtags trending, because all these are real users. These are not bots, so these are real party workers. And you can also see that there are some verified users. These are users with tens of thousands of followers that do this. So it really works quite well, and it's very well planned. Like it's you have graphics like images that are created for each hashtag in a very planned manner. So you say, for this hashtag, you can use all sets of these images. So you can say, I want to use my this tweet and an image related to sports, or image related to scams of the opposition, things like that. So it's really, really very well done. It's not just from India. So there's also people in the US. Some NGOs have used these sorts of techniques. So here is an example of a hashtag stop NRA, where again it's the same kind of example. So you send a Google sheet, and people just copy paste the same tweet again and again to get these hashtags trending. So the idea here is very general. Like it's not just about WhatsApp, but the WhatsApp bit is quite interesting, because you would not have observed this sort of external coordination if you were not a part of such WhatsApp groups, right? So yeah, we want to see now like how the spread of these information would look different if you don't observe the same common external source. So there are all these tweets in this Google Doc, but we know that all people who copy pasted each of these tweets saw it from the same source. So we know that they're all connected externally. That would not have, you could not have gotten that information if you didn't observe this external activity. And yeah, you can also use this to study information flows between platforms, like how does, how is coordination WhatsApp actually making these things happen on other platforms like Twitter. So yeah, that was kind of it. So this is, again, joint work with MIT and UFMG. Thanks, man.